let's talk about the ideal gas law. The ideal gas law is used when the gas variables are not changing. The ideal gas law, sometimes people pronounce it PVNRT. It's PV equals nRT. P and V should be something you recognize, pressure and volume. T is temperature. It needs to stay in Kelvin. What's new here is N stands for the number of moles, and R stands for the ideal gas law constant. You can find this on the back of your periodic table, or you can always Google it if you need to. The value of R depends on the pressure units. So if your P is in ATM, you're going to want to use 0.0821. If it's in kilopascals, it'll be 8.314. And if it's in millimeters of mercury or torr, it'll be 62.4. When you use these R values, it's important to remember the volume has to be in liters in order to cancel out these values. This is a little bit different from what we've been doing. Temperature, like before, needs to stay in Kelvin, and N stands for number of moles. So if someone gives you grams, then you'll need to convert that to moles. So the most important thing is to be sure that the pressure unit in the problem corresponds to the R value that you choose. Let's take a look at an example. A sample of oxygen is contained in a flask at 95 kilopascals. So my pressure equals 95 kilopascals. My volume is in this flask at 1.5 liters. And my temperature is 20 degrees Celsius, but that's not going to work. So I need to make sure that I add 273 to get to 293 Kelvin. Now, the question is, what is the number of moles? But I also can't forget the R value. So I brought them over here. Here's these R values. I'm in kilopascals. So for this problem, I need to use an R value of 8.314. The units on the R value are a little bit funny. They're actually used to cancel out all the other units. It would be liters times kilopascals over Kelvin times moles. So if you want to include the units, you really should. Those are what the units are. So let's plug it into our equation. PV equals nRT. I'm solving for N in this case. So divide by RT, divide by RT, this cancels. I get N equals PV over RT. Can use my calculator and plug this in. 95 times a volume of 1.5 divided by that R value, 8.314, divided by the temperature in Kelvin of 293. So I get an answer of N equals 0.058 moles. And I want to make sure I maintain the proper number of sig figs. I have just 2 sig figs here, so this is going to be 2 sig figs. Again, double check all of your units. Kilopascals, I use that 8.314, that will cancel. Liters is what this needs to be in, it was. Kelvin cancels, and my answer is in moles. So you can make sure that everything cancels there. Let's do another example. If I have 25 moles of nitrogen and it's sealed in a container that's 20 liters at 50 degrees Celsius, what is the pressure? So in this case, I am looking for pressure. Pressure is what I'm looking for. My volume equals 20.0 liters. Again, I'm in liters. If I was in milliliters, I'd have to convert that. My temperature is 50 degrees Celsius. Not going to work. 50 plus 273 is going to give me the answer in Kelvin, 323 Kelvin. N is the number of moles, 25.0 moles. and my R value is what I need to look on the chart for. In this case, it says, what is the pressure in millimeters of mercury? So that's kind of important, is that it's looking for the pressure in millimeters of mercury because I want to make sure I use the correct R value. The R value in this case is going to be 62.4. And again, if you want to know, that is liters per millimeters of mercury over Kelvin times mole for that R value. So PV equals nRT. This time I want to get V by itself or P by itself. So I'm going to divide by V, that cancels. I get P equals nRT over V. Put that into my calculator. 25 moles times my R value of 62.4 times 323 Kelvin divided by a volume of 20 liters. So I get a pressure. My pressure equals 25,194. I want to go through and check my sig figs. It looks like there was a decimal here. When I add it, I get to 3 sig figs, 3 sig figs, 3 sig figs. Sig figs in this number will never count, so don't worry about it. So my answer will be 25200, and the unit is millimeters of mercury. It's a pretty high pressure there. Other uses of the IGL or the ideal gas law. Since moles, N here, moles equals the mass over the molar mass, we can make a substitution into PV equals nRT by saying PV equals the mass of the substance times the R value times the temperature, all divided by the molar mass. And that comes into play in a little bit. Since density is mass over volume, we can take another step and we can say, all right, well then the pressure times the molar mass of a substance equals the mass times the R value times the temperature, all divided by the volume. Or there's a whole nother equation that sometimes I've heard called dirt, or pressure times molar mass equals density times the R value times temperature.